That's neat.
It does actually make it a lot better.
Oh, look at the excitement in everyone's eyes looking at this meal.
I'm really happy with this. I'm sure you'll find something to have, but I'll go through the list.
I'll try not to. Okay, welcome back, Spitfire Engineering. I am Gavin. This is episode 76, and this week, Archie's on holiday, so I'm in charge.
You know you've got to get a profile bit cut out for that.
You just cut round afterwards. Yeah, makes sense.
Well, considerably cheaper.
What I'm doing, I'm just welding up. I'm just welding up some rollers for an infeed hopper for an E21C. These don't have funky rollers or tail rollers like the other stuff does. Just straight tube sufficient, because it does take a bit of a beating. So that's what I'm doing right now.
So I took off an old worn cutting edge of a bucket. Pretty easy, it's just around 8 to 13 bolts depending on the bucket. Just gas axe the bottom of the nuts off, because they're coach bolts, so the actual head of the bolt is sunk in to the bucket, so they don't, wear away as the bucket works. Just gas axe them off because they're all bent and horrible and rusty. Knock the pins, knock the bolts through, and then just lift it off with a magnet. Safest way really, and then throw it away.
so today I'm doing loads of cut lists for projects that we've got going into the yard, which is something we don't really show. So that footage is me doing the cutting lists so that the boys can cut it, and then I'm going to print the drawings off in a second and hand it over to Lauren, who then hands it over to the boys. But this is a small project, so we don't do a start meet or anything like that. We'll just pass it over and the boys will crack on with it.
Tuttle, tuttle, tuttle.
Right, so today I'm fabricating a replacement shaker deck for a customer. As you'll see from the footage, it's quite a big shaker deck. So yeah, just working on this at the moment. I'll get a good chunk of this done today. Hopefully get it done tomorrow, depending on how things work out. But yeah, just follow along and see how I get on with it.
It does actually make it a lot better.
Oh, look at the excitement in everyone's eyes looking at this now.
I'm really happy with this. I'm sure you'll find something, yeah, but I'll go through the list of things.
I'll try not to. And so you've got a slot on the runner at the top, and you've also got a slot in the door. So you've got
a slot everywhere. You've got slots up here, slots in here now.
So that's 7mm based on that door sitting bang in the middle of the slots.
So I got to 10. For some reason I had 20, but I didn't. I had 10. But obviously lost a bit of that now because I've changed that plate to 5mm. So move door out, slots on the top and the sides, which we just spoke about, and remove coach parts, which is what we've done. Door locking plate, slots on that as well. Thank you, Mel.
Does that sit level or could tuck behind if you wanted it to?
That would have to come out further to do it. I mean, you could. This house normally has to be that height to cover everything else. I mean, you could bring that further up and go along, but is that then going to cause you grief putting it on and off? I don't know. Rubber stop under the door. What I've done is moved that first one over, which was the one you wanted to push in and out.
Has this ended up a little bit taller?
I've had to make it taller, otherwise
Is that an issue with transport?
150mm taller. These all now go as high up as that channel that we said about. I've had to go 80 by 80 channel, not channel, angle.
Is that folded?
No, you wanted to do it.
Are we notching it out?
Yeah, that's what you've asked me to.
Yeah.
I've already here, angle for 90, brought in, not bent. I've then put the brace on this side. It's not in the centre deliberately, because then you can have even panels for your roof. So you put your channel in, didn't you? Put your roof on, put your box section on, fill it with concrete. The locking panel comes all the way up, so nothing can get in it. The infill plate that covers the door it's hard to see. I've got a fold on the side and a fold on the bottom, so there's no gap. So when you come to put concrete in it, it can only fall down there, and then down the three other sides that we want concrete to go in.
I think if you two are happy with this, we should build one. Put some concrete in it.
And see what it works.
And wait.
Cool.
It does.
So that was the meeting about the site bank. Now, obviously we've made a few of these units now and we're still tweaking the design. Hopefully we've now got it sorted. One of the major things that we're looking at doing is reducing the weight down to around the 2.5 ton mark, so it can then be moved on like a Land Rover and trailer type sort of setup. So that's what we're trying to do, but we're trying to do that without compromising the security of it. So we think we've got it right now, so we're going to crack on and make one, just to make sure that we're happy with the design, and then once we've done that and we're happy with the design, that we're going to crack on and make a load more. Okay, Wednesday morning, first day I've had a chance to have a look around the workshop this week. Been a bit busy. Archie is off this week, so not quite sure what Adam's got filmed. I think he has filmed different bits and pieces from the last 2 days in the workshop. But let's just have a little walk through the workshop and sort of bring you up to speed of where we are with different things. So in last week's episode, you saw this being put together.
Pardon? No, I'm doing both so it doesn't go too far forward.
They've got the conveyor on the top probably doesn't make a lot of sense to people. What we're having is a conveyor with some deep brush strips, which are, I think they're still in the office to be fair, some deep brush strips that will go onto some aluminium brackets and be bolted through the rubber. So instead of a conveyor belt thing sitting on the conveyor belt and going up, we're just using the conveyor belt with brush strips. And the idea being, if you come around here, Adam, I'll show you. So inside the tank, the material will float, and then the brush will come around behind it and sweep it, and actually sweep it up this ramp here. And as it's sweeping up there, the water can drain back into the tank, and then all the light material will just come off and fall off here onto the floor. So that's how that works. So when we talk about the conveyor and that, it is a conveyor when you look at it and that, but it's not being used in the sense that you would think of a normal conveyor, which is what is going out the other end. Fans turned up. As I said last week, that is going to be mounted underneath there because there is a hopper that sits on top of here, and actually this is here. So this unit here is going to sit above where the material is going to go in there, and the idea is we've got two sides inside there which bring the material like that. So what we're trying to do is we're trying to create the material to fall through the gap into a band, so the material can be however wide and it falls through into a band. And then on the other side of this there will be a big tube, which is that tube standing up there. There's a big old tube there which will connect into there, and that will connect to the fan, and the fan will act like a giant hoover. So as the material's going in here, anything like polystyrene balls or any dust or anything like that that could clog the water up, we're going to extract it at this point. Obviously in the summer that's probably going to be a little bit more effective than it is this time of year in the winter. But that's the idea of that, so that those two sides there, the material goes in, it creates a wide band that's no more than say 8 inches across, so the air can rush in this side, any light stuff can then be removed out of the material stream, sucked out the other side, and then it'll go through the fan, and then the fan will have another hose on it which will end up in like a 40-yard skip with a net on the top. So if there is any little bits of paper or plastic or polystyrene, it'll all end up in the skip. So that bit there will get fitted up onto there once this has been painted. I did notice the other day that this flange here, where it had welded, had slightly warped. Lads have managed to get that back straight, so that's pretty good. There's some bolt-on pieces to go on here, which are the lifting points. But yeah, we're just waiting on the pipework now. Some of the pipework has turned up. Let me see what there is. It's just the pipework up there, but there is a load of valves and stuff, which I'll find them and I'll show you in a minute. But yeah, we're just waiting for the final piece of the pipework because we've got to just finish welding on an elbow down there. I think there's a flange to go on there and a bower coupling, same there. So just waiting for all that to come together so we can finish that off. Steve's been doing the tank in here and the dewatering screen. This is the first time I've seen this.
Is it?
Yeah, this is the first time I've been in here a week. So obviously we've got the tank, which is going to sit to the side of the main machine, and all the water will go eventually into here. But mounted on top of this is going to be this dewatering screen. Now this at the minute is obviously on its side. That's the bottom. This is the top. And then there's 2 vibrating motors that go in there. That's got to be 600 mil across. Is it 600 mil across, Steve?
Yes, 632 inside.
632 inside, and
2 mil tolerance.
we're bang on, are we?
Oh, about a mil.
You're about a mil.
Yeah.
So it's within tolerance. That's good. So the idea is that this will come down flat and sit at I think it's about a 1.5, 2 degree angle. So what we're going to do is we're going to use vibration to vibrate the solids uphill. So it will sit with this end slightly lower. The material will come in this end through this hole here. There'll be a fitting on there. That's actually got to go a bit bigger, isn't it, that one?
Yeah.
Yeah, because we're going to go up a size on here so that the water coming out of the main machine into here is obviously it's going to flow through gravity. So we've had to increase the bore size because we've got 3-inch pipework with pumped water going in. And I thought if we had 3-inch coming out and it's under gravity, we could end up just filling it up and filling it up. So the idea is we're going to do this as a bigger bore pipe so it flows easier as it comes out. And then the idea is that the screen mesh in the bottom sits at an angle as well. So the material will collect in the bottom here, and then when we're not expecting this to vibrate all the time, we're actually going to have a timer. Sean's actually coming in today to discuss about this, Steve. So we're going to have it on a timer, so it might kick in every couple of 3 minutes, or maybe in the summer when there's not a lot of solids in there, it might be every 10 or 15 minutes maybe. So we're going to have a timer on it so that this just kicks in for like a minute at set intervals, just to clear itself off. Because in essence, this, although it's a dewatering screen, which is generally used in wash plants for removing sand from dirty water and obviously dewatering at the same time, we're actually using this as like a water filter for just keeping the water clean so it doesn't get clogged up with too much dirt in the bottom of that tank. So as the material goes up here and the water falls through, the water will then run back down this here to drop into that tank there. And that's basically what it's going to do, isn't it? There we've got these 2 beams here. They're bolted to this, aren't they? And the idea being that this tank is slightly wider than the dewatering screen. So, because this tank might have a build-up of sediment every now and again, it's going to have to be cleaned out. So the actual screen finishes about here. So you've got, and there's some grids, I think, to go down the sides, isn't there? Yeah. There is some grids, isn't there? And then some grids down the sides that can come out so they can pressure wash it all out, clean it all out, start again. That's the plan. So that's the dewatering screen from the float tank. Rob's working on a new project in here, doing a vibrating feeder for a customer as a replacement for one of their old feeders. So Rob's just putting that together in here. We've had to buy in a set cut piece of steel for that because it was bigger than a normal size. So we've had to get a special bit cut and bought in. I don't think there's anything in Connor's bay next door. What's he doing? I think what's Connor been doing? He's on mini screens. We've got some more mini screens going through the workshop. We've got one that's going out in February, and then there's some others, I think. We're taking orders now. I think we said this a few weeks ago. We're actually taking orders now for going out in the new year. People have been paying a low deposit. This one customer actually, he's been paying a bit every month. So by the time he gets his machine in February, he's already paid for it. So he's happy, we're happy. And if anybody else wants to do something similar or pay a low deposit now to secure a build, because these are going to fly out next year. There's a lot of effort gone into sales on these the latter part of this year, which is really ramping up to being quite busy on these in the spring. So if you do want one of these machines, put your name on one now, because we are building for stock, but we might not have machines available in the spring because we've got quite a few people already interested. Fingers crossed we'll be okay, but you just never know. Let's go and have a look and see what they're doing out here. So this is the heavies conveyor for the float tank at the other end of the workshop. Fully stainless, because this is actually going to be submerged in water. This is. Now we've had to design this a little bit different to normal because it's going in water. So stainless steel for a start. This is what you call a slider bed design. So that flat piece of steel there is what the belt will run on. Because obviously I didn't want rollers in there, rollers running in water. So we've done a slider bed, which means that we have to use a different belt. We have to use what's called a fabric backed belt. So on the back of a rubber belt, normally you'll see the black rubber on there. If you look underneath and it's sort of like a brown textile type material, that's what they call fabric backed. And that's got a low friction surface for running across. You know, if you put a rubber belt on there, it would take a bit of dragging over the top. So with a fabric backed belt, you lose the resistance and it pulls it over. One other thing that we've had to do on the bottom on this, when we do this, we're going to have to get the conveyor running and run it out of the machine, get it tracked and make sure we're happy with it. And then we're going to have to put it in the machine after we've done all of that. Now at the bottom here, we've used special bearings that we've actually made ourselves. We've actually machined some nylon block bearings to go in here. So there is no bearing in there as such that you would know. It's basically a nylon bearing that's designed that will eventually wear out, but it's not a particularly fast moving conveyor, this. And obviously you've got the water in there that will act as a bit of a lubricant, but you can get certain engineering plastic materials that have got certain like naturally lubricating properties. So we're actually going to use them in there. I'll show you them in a minute actually, because they're in the machine shop, I think. So we've got them in there, tail drum in there as normal. I think I've just seen that in Connor's Bay or in Rob's Bay. So that will get put in, but we're going to have to move the float tank out to put that in. So I think that's why this is sat here at the minute. We've also got in here this, which is an infeed hopper. A few weeks ago, a mini screed E21C went out. Customer come and picked it up about 2 or 3 weeks ago, and he ordered a infeed hopper. So this infeed hopper will sit above the deck screen, so you can tip a load of material in it, and as it's going out, it meters it out and falls onto the deck screen, and then whilst you're going off and clearing away the oversize or the fines, or getting another bucket full, because deck screens like it when they're fed little and often, you know, a nice constant feed of material, because if you put a lot of material onto a deck screen, it bogs itself down on its springs or roster mounts, and you lose that vibrating action, and it's not the most efficient way of loading a deck screen. So if you can give it a nice constant feed, actually slow is more, you'll get more out of it. And that there is the hopper to go above it when it's done. So we're just assembling this now. We've been waiting for the customer to tell us about the orientation of the greedy boards, which I think they've done this week. And this can all be put together, and then at some point we can go to site to fit it. But the customer did say this week that his material's quite damp, so there's no massive rush on this, but we'll get it done anyway, and we'll get it fitted when we can. Okay, so this is the take-up bearing that we're going to use on the stainless conveyor for the float tank. So Colin's machined this. This is a special engineered plastic that's got oil impregnated into it somehow. Don't ask, I don't fully understand, but I do know that you can buy this sort of stuff and it's got lubricating properties for exactly what we're trying to do. So Colin has machined that out of a piece. It was actually out of a round piece, I think, by the looks of it, that we had in stock for another job left over. So we've got 2 of them, and that's what's going to be used in there. So all done in-house here at Spitfire. Right, let's go and see if we can find these pipework valves. So these are the couplings. That's one half of it. Not all these bits are here yet. So we've got some threaded collars that we'll weld into the tank. So we'll weld that bit into the tank, and then these fittings here we'll screw into it with some PTFE tape around there to seal it up. And then that will screw up into there and go tight. And the idea being that then that can connect onto there, and we can have it so that the pipes that connect up, or the ones that are probably going to need to be disconnected to drain it down, we've got the fittings here to sort the job out. That's the plan anyway. So we're just waiting for the last few bits of them to come in, and then the lads can weld them onto the tank in there. So that's that bit. These two conveyor belts here are for the float tank, and I was just saying a minute ago about the fabric backed belt. This one here is going to be the one that's going to have the brushes bolted to this. So you'll see in there how that's black on both sides. Well, this one here, you can see it's got this material on here, what I was saying about being fabric backed. So that's quite slippy compared to that. So the reason we have this is so that that can slide over, like we say, the slider bed with a stainless sort of flat tray in it. So fabric back belt, rubber back belt. So this week's fun fact, have you ever heard of an aeroplane called Spitfire? Now I know Andrew's done some company updates from Lauren's desk, which seems to be the centre of things that have gone on in the last few weeks. So I've just come down here to do a voiceover with Adam for an advert that we're running at the minute. And I said, well, let's do it here because this seems to be the place where we're doing things nowadays. So this week's fun fact is all about the Spitfire aeroplane. Now, believe it or not, even this week, somebody has asked me if we have anything to do with Spitfire aeroplanes. It does crop up quite regularly, to be honest. So this fun fact, Spitfire aeroplanes. So apparently, and I didn't know this actually, the Supermarine Spitfire was designed with elliptical wings by a guy called Archie Mitchell in the 1930s. So it was one of the first aeroplanes that had elliptical wings, and it says here, the shape reduced drag, allowing the aircraft to fly faster and turn tighter than almost any rival. Its lightweight stressed skin structure made it both strong and agile, perfect for the Battle of Britain in 1940. So I'm assuming that's the shape of the wing, isn't it, really? That makes it a little bit iconic. And yeah, a guy called Archie Mitchell in the 1930s come up with that. So that's this week's fun fact, all about Spitfire planes. So that's it for this week. Like, subscribe, all the usual stuff, and we will catch you on next week's episode.
This is ASMR with George.
You're rolling. They see me rolling.
I'll get my words out eventually.
Lauren, just so you know, Adam's moved all your desk around and he's panicked that you're going to come tomorrow and realise that he's moved stuff on your desk. But I won't say anything. Just put that in there. In the screenshot. See, we have stuff delivered all the time, right? Sweets, biscuits, everything. I pay the bills around here. I never get to see stuff like that. It always ends up down here. It's like Adam, Lauren, and George, they snaffle everything. Nothing ever gets itself upstairs. Not this one. This one, I'm keeping this one.